In this video, I will discuss how you identify extraneous solutions when you have an absolute value equation. To start off, what is an extraneous solution? It's a solution that doesn't satisfy the original equation. So in the end, you're going to get your two answers, but when you plug them in, one of them may not actually give you a true statement in the end. So we'll kind of go through a few examples to see how this would look. In this first example, our absolute value is already by itself. So we can go ahead and start splitting it up into our two equations. So we'll have 2x plus 12 equals 4x. And then our second equation will be 2x plus 12 equals negative 4x. Now we can go ahead and solve these. I'm going to start by subtracting 2x from both sides. And then I will divide both sides by 2. So we'll get 6 equals x. You could also write it as x equals 6, however you want to write that there. The second equation, I will also start by subtracting 2x from both sides, and then I will divide both sides by negative 6. We'll get negative 2 equals x, or you could write it as x equals negative 2. So how do we know if either of these are extraneous solutions? Well, let's plug them back into the original equation and see what happens. So for x equals 6, we would have 2 times 6 plus 12, absolute value, equals 4 times 6. So if we start to simplify, 2 times 6 is 12. That's still in the absolute value symbols. And then that's going to be equal to 24. And the absolute value of 24 equals 24. And yes, we do get 24 equals 24. So x equals negative 6 is an actual solution to the equation because we end up getting a true statement. 24 equals 24. Let's try x equals negative 2. When we plug in negative 2, we want to definitely make sure we're using parentheses because we have a negative in there. We don't want to think of this right-hand side as 4 minus 2. It's 4 times negative 2. Now we can go ahead and start to simplify. That is a negative 8. And so when we do this, the absolute value of 8 is 8, but then we get that equal to negative 8. So that's a problem because 8 and negative 8 are actually not equal. So this solution is an extraneous solution. Another way you could see it is right in this line here. We have an absolute value equal to a negative number. You can see it here too. An absolute value can never be equal to a negative number. So whatever happens on this side, even though the absolute value is isolated and you can start to simplify, it's equal to a negative number. Absolute values always have to be either 0 or positive. So this x equals negative 2 is not a solution to this example. It is an extraneous solution. With this next example, we have an absolute value equal to an absolute value. So when we write our first equation, we write it just by dropping all of the absolute value symbols. The second equation, we drop the absolute value symbols, but we make the right-hand side negative. So we want to make sure that there's parentheses in there so we can distribute that negative to both terms. I'm going to start off by solving the left-hand equation. To do that, I'm going to subtract x from both sides, and I will get 5 equals 11. This is not true. 5 will never equal 11. And in this case, this is kind of where that extraneous solution comes in, because one of the equations that we made ended up not being solvable. We won't get a solution for that. So in this example, we actually may only end up with one solution, but possibly no solution, depending on what the other equation gives us. So going to that second equation here, we want to distribute that negative, and just remember that's like saying there's a negative 1 out front. So we have negative 1 times x, which gets us negative x, and then negative 1 times 11, which is negative 11. To finish solving, I'm going to add x to both sides. We get 2x plus 5 equals negative 11. I'm going to subtract 5. We get 2x equals negative 16. And then by dividing both sides by 2, we get x equals negative 8. So this may or may not be an extraneous solution. We just have to plug it in to then figure out whether or not it satisfies the equation. So if we plug in -8 for every x that we see, we can go ahead and start to simplify. So -8 plus 5 will get us -3, and then -8 plus 11 gets us a +3. And if we take the absolute value of both of those, the absolute value of -3 is 3, the absolute value of +3 is 3. So yes, this is a true statement, which means that our original solution, x equals -8, is a solution to the absolute value equation that we have. So in this example, we only end up with one solution because one of the equations we started to solve was not actually solvable. And that is how you identify extraneous solutions.